The second type of symmetry is called a translation. The idea to a translation is you're trying to slide a piece over and over again to create the design. So, for example, if you look at the very first one right here, if we can outline a piece that can be moved over and over again, and we're looking for the smallest possible piece, we're going to slide it over, draw it again, slide it over, draw it again. So if you look, let's see, if I outline this piece right here, if I were to move this piece over and over and redraw it, it's going to create the entire design. So I could slide it to the right. Notice it's the same. That's not the only piece that you could slide around. There are others, like for example, I could slide this piece around to create the entire design. If I draw it again, slide it to the left. No? Notice, same design. If I just keep on sliding it and redrawing it, I could create the entire picture. That's the idea to a translation. Now, we are going to take pictures and actually draw the translations out. First, just like reflection, there are two things that have to be true. Take a look. If I draw a line from A to A prime, draw a line from B to B prime, C to C prime, D to D prime, and E to E prime. Notice it's going in the same direction as the arrow. Yeah? There are two things about all the lines that have to be true. If you want, just focus on A to A prime. Okay, the first thing has to do with distance. The distance from the original point to the image is the same length as the arrow, which should make sense. So if you look from A to A prime, it should be the same length as the arrow because that's how far we have to translate the picture. If you look at B to B prime, this right here should also be the same length as the arrow. If every point moves the same length as the arrow, the whole picture moves that distance. Does that make sense? The second thing that has to be true. If you look at all the lines connecting the original to the image have to be parallel with the arrow. So if you look, all these lines are parallel. Now, it's not enough to say that the lines are parallel to each other because they could be going in the wrong direction. It has to be parallel with the arrow because that's the direction that we have to move. These are the two things that have to be true in order to have a correct translation. Once you know these two things, we're going to use them to help us actually translate a picture. We are going to move that crown-looking picture in the direction of the arrow. Now, in order to do this, think back to when we were doing the reflection. Here's a picture. Look at all the lines that connect from the original to the image. Notice they're parallel. Every single one of these lines are parallel. They're not the same length though, which is what we need for a translation. So, if we can just have a guideline to help us draw those lines parallel, then we can move the picture in the correct direction. So, here's what we're going to do then. We are going to draw a line that's 90 degrees to the arrow. If we draw a line 90 degrees to the arrow, we can use that as a guideline so that we can make parallel lines with the arrow. Okay, that sounds kind of confusing, but just here, follow along. Okay. First, I'm going to take my protractor and I'm going to line it up so that it is on the arrow right through 90 degrees. Once I have it lined up, I'm going to draw a line along the bottom right here. And I'm going to use that as my guideline. I'm just going to make it really long. That way I can guide the protractor with it. Once I have that guideline, I'm going to slide the protractor along that guideline. all I need to do is go to the first vertex. Keep it lined up to the center and 90. At the first vertex, I'm going to draw a line right along the bottom. Do that for all the corners, and then we'll come back and then I'll show you what else to do. Using the protractor, we draw all these lines. We just slide the protractor along the guideline, and every single line out of the corner should be parallel. So that's the first quality. The second thing that has to be true is it has to be the same length as the arrow. So we need to measure the arrow. I grab my ruler, the arrow. Now you're measuring from one end to the other, tip to tip. My arrow is 43 millimeters. It's going to be different on yours again because mine is scanned into the computer. So you have to measure it on your side. My arrow is about 43 millimeters. So starting from each corner, you're going to place a dot 43 millimeters away. You're going to measure from this corner, count 43 millimeters, and place a dot right there. And we do that over and over. Remove the ruler, starting from the next corner. You measure 43 millimeters, place a dot right there. Okay. So from every single corner, measure 43 millimeters. I'm going to finish up, pause the video. As soon as you're done, come back. Once you have all the dots, all you need to do is connect. So we'll connect in the same order that we see the original picture. Starting from here, connect to this point. Starting from here, to this point. Okay. From here, and there you go. So all you need to do then, draw a guideline 90 degrees with the arrow, run your protractor along this guideline, and draw all the lines parallel from coming out of each of the vertices. Once you have all these lines, you measure the arrow. Whatever that length of arrow is, starting at each vertex, you're going to measure the same amount, place a dot from every vertex. Same measurement. Once you have all the dots, just connect them and you should have the shape move, translated the distance of the arrow.